All right, this is chapter 5, day 7. At this point, we've covered a lot, and we're going to be going over some of the strategies to handle some of these probability problems. And the main strategies are going to be the Venn diagram and the tree diagram. The tree diagram is going to be used for independent events. The Venn diagram is going to be used for events that you're not sure if they're independent or not. They're probably not, and they probably contain the word both in there. The Punnett square is something that a lot of students are familiar with from their past. We will not be using the Punnett square. There's something wrong with it, but we're not going to use it. We're going to use the tree diagram as a substitute for the Punnett square, which you may have learned earlier. All right, let's go over a few things. Just recall from general things. This symbol means intersection. This is where things overlap. And that overlap area is right here on the Venn diagram, okay? And the intersection of two things is the product of A and B. If they're independent, it'll be the multiplication of those two, okay? And remember, there's a word disjoint. The more common word for disjoint is mutually exclusive. And that means two things cannot happen at the same time, okay? And if two things can't happen at the same time, then their intersection is 0, okay? Now, the formula for adding things up will be probability of A plus B minus their intersection. You see that? If their intersection is 0 and they are mutually exclusive, then it's just probability of A plus B. So this formula is absolutely crucial to remember. The intersection can be 0, it could be their product, or it could be a given number. Those are the three ways that you find the intersection. Multiplying if they're independent, some given number in the problem, or it's 0 if the events are disjoint or mutually exclusive. So you got to know that, and you got to know that A times B is the intersection if they're independent. Those are the two main things we're going to look at. And we're going to be using a Venn diagram if the key word is both, and otherwise we're going to use a tree diagram. We will not be using a Punnett square. I have it here because I know you're mostly familiar with it. Okay, let's jump into these problems. Okay. First problem. In any given month, the local hospital performs 2 types of surgeries. 65% of their surgeries are category A, whatever that is. The rest are B. Surgery A has a 95% success rate, while surgery B has an 80% success rate. Find the probability that a randomly chosen surgery patient, and then I have a couple of questions to ask you. Okay, so the first thing you should realize when you're doing this problem is it doesn't have the word both in it. So this problem is going to be a tree diagram. So when you do the tree diagram, the first thing you're going to write out, and these have to be complements, surgery A and surgery B. Notice these two numbers add to 1. So you got 65% and 35%. We're going to subdivide surgery A into their success rates. 95% are successful, which means 5% are not successful. And if you multiply these numbers out, you will get these two numbers. Notice that these two numbers add up to 65%. All we've done is subdivided the 65% into 2 areas, successful and not successful. And we're going to do the same for B, because 80% of them are successful, 20% are not. So we're going to multiply 0.35 times 0.8 and get 0.28, and 0.35 times 0.2 and get 0.07. Notice that these two numbers add up to 35%. All four of these numbers will add to 100%, because that's all the things that can happen, okay? So, what's the probability that they had a successful surgery? There are two branches that are successful surgeries. It is this branch right here, and it is this branch right here. So if you just add those two branches up, you will get the probability of a successful surgery in general. Okay? And the second question is, had an unsuccessful surgery given it was category B? Had an unsuccessful surgery given it was category B. Okay? All right, well, category B is these two added up. Okay, category B. And of course, that makes 0.35. And then the unsuccessful surgery was this one right here, 0.07. And if you divide that, you will get 20%. Of course you're going to get 20%. We already know that unsuccessful surgeries in category B happen at a 20% rate. But that shows you that this conditional probability is the inverse of the multiplication. Okay, so there's that problem. Let's go to the next one. The next one is going to be a Venn diagram, as you can see. 70% of LQ students are enrolled in a foreign language, okay? 45% are in arts, and 30 are in both. Find the probability that a randomly selected student has, and then I have several questions. Okay. First thing you do when you fill this out is you always start in the middle. The middle is both. So this 30% goes in the middle, okay? Now, 70% are relative foreign language. I put EL, or no, FL, foreign language, FL. Notice that these two add up to 70 because this whole bubble, which I should probably highlight so you can see it, this whole bubble right here should add to 70% because 70% are enrolled in a foreign language. So to get 40, I had to go 70 minus 30, okay? And the same can be said for the art class. The art one I'll put here in pink. This entire bubble needs to be 45%. So in order to get the 15%, I have to go 45 minus 30, okay? And then as you can imagine, the last number out here represents kids that didn't take a foreign language nor an art class. And that is 1 minus the summation of these numbers. 40 and 30 makes 70, plus 15 is 85. 1 minus 0.85 is 15%. I put them in whole numbers. They could easily be decimals. Okay, only a foreign language elective. So only a foreign language elective is just this one right here, just that 40%. Once you draw the picture, it almost answers itself. Neither a foreign language or an art. That one is this 15% right here. So item 2 goes to that 15% right there. Only an art elective. That one is going to be this 15%. Okay? And then the last one looks like it asks a conditional question. A foreign language given he's in art. Okay, the word given means that is going to be the denominator. So given he's in art. So I'm going to circle the art part, given that he's in art. So we're only dealing with that particular bubble. So given that he's in art, that's 45% right there. A foreign language, 0.30 over 0.45, and that ends up being 2/3. Okay? So those conditional questions limit what you're going to be looking at. And so when you see given, that becomes the denominator. Okay? All right, let's go on to item C. Item C, 12% of teenagers own both an iPad and an iPhone, which I listed as phone and pad. While 26% own only an iPhone. 42% own either and do not own either an iPhone or an iPad. Okay. Find the probability of randomly selecting a teenager who, and I have all these questions. Okay? All right. Let's first start in the middle. In the middle is where both go. So you got to start with 12% right there. Okay? This 26% owns only an iPhone. Only an iPhone is right here. Not just 38% own an iPhone, but only an iPhone is 26%. And then 42% own neither of them. That goes on the outside. So in order to get this particular 20, I had to go 1 minus the summation of 42% plus 26 plus 12. Once I got that, I would be able to get 20%. And once you get the drawing, then it's really easy to finish it off. Okay? Owns an iPad. So owns an iPad would be 12 and 32, 12 and 20, making 32. Owns an iPad only. Owns an iPad only. That's this 20 right here. Owns an iPhone or an iPad. An iPhone or an iPad is going to be these three added up. Okay? So you can do this question actually two different ways. The first way would be to go 26 plus 12 plus 20, and that makes 58. The other way is to say 38% own an iPhone, 32% own an iPad, but I got to subtract out the overlap or the intersection, which is 12%. That will also make 58% when you're done. Okay, so there's two ways to do that. And then the last one, number 4, is owns an iPad given he has an iPhone. Owns an iPad given he has an iPhone. Okay, so given he has an iPhone is this right here. That becomes your denominator. Given he has, so the bottom number is 38%, 0.38. Then the top number is within that bubble only. Where does he own? Where does he own an iPad? Right there, the 12. 0.12 over 0.38, and we get 0.3185, which is 31.58%. Okay? All right, so far so good. Okay, the last 3. Last 3 here on this section. In a recent survey, 38% of students own an Xbox, 40% and a PlayStation, 12% both. Find the probability of randomly selecting a student who, all right, both is the key word. Once I see the word both, I'm going into a Venn diagram. And I put the both right there, 12%, okay? Now, 38% own an Xbox, so to get this number right here, I had to go 38 minus 12 to get 26. And in order to get this 37, I had to go 49 minus 12 to get 37. Then I add all 3 of these up and subtract from 100, and that leaves the area of the kids that own neither, okay? All right. So let's check this out. Owns only an Xbox. Only an Xbox will be this particular 26% right there. Owns only a PlayStation. Only a PlayStation will be that 37% right there. and doesn't own either. That's this one right here, that 25%. Okay? Now, the last one is a PlayStation owner who also owns an Xbox. Is a PlayStation owner who also owns an Xbox. This is a fancy way of trying to get that number to come out. Is a PlayStation owner, you're in this bubble, that also owns an Xbox. Right there, 12%. Okay? All right, next problem. 11% of road accidents involve motorcycles. Okay? Of motorcycle-related accidents, 29% are fatal. But in non-motorcycle accidents, the fatality rate is only 7%. Find the probability that... All right, now, you don't see the word both. This is a tree diagram for sure. We start with motorcycle accidents and non-motorcycle accidents. They should add to 100, and they do. 0.11 is 11% are motorcycle accidents. 89% would be non-motorcycle accidents. These add to 1, okay? Now, I'm going to take the motorcycle accidents and I'm going to calculate with the fatality rate. 29% are fatal. There's the 0.29. And then that means 71% are non-fatal. So to get these end numbers right here for the motorcycle, I have to multiply 0.11 times 0.29 to get this, and 0.11 times 0.71 to get that. These two numbers will add up to 11% because I've subdivided the 11% of the motorcycle accidents into fatal and non-fatal. Now on the non-motorcycle accidents, presumably cars, buses, they have a much lower fatality rate for obvious reasons. 7% goes there and 93 goes there. This adds to 100. And if you multiply 0.89 times 0.07, you'll get that. And 0.89 times 0.93, you'll get that. These two numbers add to 89%. And all four of these will add to 100%, because that's the four categories that we have. We have motorcycle and non-motorcycle accidents that are fatal or non-fatal. Those are four things. All right, so let's go through these. Suffered a fatality. Okay, so a fatality could happen. There are two branches of fatalities. One is the motorcycle branch, and one is the non-motorcycle branch. So you want to add those two up, and that gives your overall fatality rate in an accident in general, just under 10%. Did not suffer a fatality. Well, not suffering a fatality is also two branches, okay? And there's several ways to do did not suffer a fatality, but the first way to do it is to go 1 minus that answer, okay? The other way to do it, of course, is to add these two branches right here. You could add those two. That will also give you the same answer. So I did it one way here, and you could also just add it there. No problem. Okay, item Roman numeral 333 there, whatever that is, 3. Suffered a fatality given it was motorcycle related. Suffered a fatality given it was motorcycle related. All right, so the motorcycle related ones, and by the way, this line means given that. Given that it was motorcycle related. These two, you got to add those up and put those on the bottom. 0.0319 plus 0.0781. And on top, you're going to put suffered a fatality, which is 0.0319. Okay? If you do that, you're going to go back to 0.29, which is what we know is the given fatality rate. That's pretty easy. Okay? And then the last one there got cut off. Let me move that up slightly. Okay, let me move that up. Okay, it was motorcycle related given it suffered a fatality. Was motorcycle related given it suffered a fatality. Okay, so I'm going to go back and we'll check that out. Okay, all right. was motorcycle related given it suffered a fatality. So suffering a fatality is this branch and this branch right here, which we know is 0.0942. 0.0942, okay? And then on top, we need motorcycle related. And motorcycle related is 0.0319. Okay? If you carry out that fraction, you're going to get about a third. A third of all fatalities are motorcycle related. That seems high, but if you think about it, motorcycle accidents are at a low level, but they're highly fatal. So overall, you end up with a large number of fatalities that end up being motorcycle related. And I'll pop the answer up here in just a second. Yeah, it's 0.33, as you can see there, 0.3386, as I move that around a little bit. 0.3386, okay? All right. All right, last one here. Mr. Nguyen's students got A's. 35% of Mr. Nguyen's students got A's. 40 got B's, and the rest got C's. Okay? 85% of the A students scored proficient on the state test, which makes sense. 70% of the B's and 55% of the C's. Find the probability of a randomly selected student who, and I have some questions. All right, this is a tree diagram, but it has 3 branches. Okay? Here's your A students, 35%. Here's your B students, 40%. And here's your C students, 25%. Okay? Now, 85% of those A's were proficient on the test. 15 were not. 70% of the B students were proficient on the test. 30% were not. 55% of the C students were proficient. 45 were not. And if you carry out the multiplication, you get 6 totals there, and they add up to 1. Okay? So, first question, scored proficient. Well, scoring proficient is going to be this branch, and this branch. There are 3 ways to score proficient: getting an A and be proficient, getting a B and being proficient, and getting a C and being proficient. Okay? And there's your answer for this one. Okay. Did not score proficient. Obviously, I can go 1 minus that answer. Or I can simply go, I can add these 3 branches up here. I could actually add some different branches up, okay? I could add that one, and that one. That didn't come out very good. Try that again. Okay. I could add this one, and this one, and get the same answer. Either way, okay? All right, the next question. The next question is, got an A given they scored proficient. So given they scored proficient, we know scored proficient is 0.715. So that's going to be my denominator, okay? .715 is my denominator, okay? Then got an A. Got an A is this branch right now of the proficients, 0.2975. And then I just simply carry out the math and I get this, okay? And the last question got cut off, so let me move that again. Okay, the last question is, scored proficient given the student got a B or better. Scored proficient given the student got a B or better. Okay, so what's the probability that you got a B or better, okay, which is a B or an A? You're going to add up all 4 of those, okay? So that's going to be, basically it's going to be these two, which is 0.75, B or better, okay? And then scored proficient is going to be this branch right here and this branch right here. So 0.2975 plus 0.28. Okay? So it's going to be this divided by that, and that'll be your answer, which I'll show in just a minute. Okay, it ends up being 0.77, as you can see. Okay, now these last two problems are really interesting, and I'm going to leave the answers up, but I'm not going to walk through them because we'll probably do them in class. Okay, but you guys can stop the video and you can kind of get the answers if you want ahead of time. Okay, and that concludes Chapter 5, Day 7, the last two tree diagrams we will go through together.